Hello again everyone, welcome back to ptet.chemistry channel. So this is the last part of this multi-part tutorial series on chemical formulas and equations. So we've learned a lot about chemical formula for the last couple of lecture tutorials in this topic. We are ready to write word and also balancing chemical equations, which remained one of the most difficult things to do even for the pure chemistry students. And only after you master doing these balancing equations, only then we can move on to the next topic, which is basically on reacting masses, calculations, which are all based on your balanced chemical equation. So basically what we know is a chemical equation will summarize what happened in a chemical or reaction, I guess. What is important is conservation of mass. So it's not stated here, but whatever that goes in must come out. So the total mass going in, the total mass in must be the total mass coming out. That's why every single atom on the left hand side of the equation, every single atoms on the reactants are on the left, reactants react and they give you products or they form products. So whatever that comes out in the products come from the reactant. So for instance, carbon burns in oxygen and you get carbon dioxide. So what will happen with, let's write down in words first, carbon plus oxygen, then they will give you carbon dioxide. So each of these are substances which you have come across, whether you have done lower secondary science or whether you have actually watched my previous tutorials. Well, at least in my year 9 lessons, there's something that I will have covered with the students. So carbon is an element, oxygen is an element as well. Carbon is element number 6 in the periodic table. So the chemical formula for carbon is just carbon. And then oxygen. Oxygen is one of those diatomic. Recap back on the first part or the second part of these lecture tutorials. So some gases, some non-metal gaseous elements are diatomic molecules such as H2, O2, N2, F2, Cl2, Br2, I2. Not all of them, only these particular examples. So oxygen is O2, as you know from your covalent bonding topic. And then carbon dioxide is a covalent compound, as you know from your covalent bonding topic again. It's CO2. As you know, carbon form 4 covalent bonds because carbon is in group 4. So they want to share 4 electrons, so they form 1, 2, 3, 4 covalent bond. Oxygen is in group 6, so they want to share 2 electrons to complete the outer shell. Oxygen only form 1 and 2 covalent bonds. If I show the dot and cross, it will look like this. Of course, dot and cross are basically something that you will have done a couple of months ago prior to doing this particular topic. And after using 2 out of 6 for covalent bonding, I still have 4 more in my outer shell. So that is my correct dot and cross. Anyway, this topic is about balancing equation. These are just recap on the things you have done before. So balance this equation. Number of atoms before the reaction, that means on the left hand side, that means the reactants are on the left hand side. Let me improve my handwriting a little bit. Reactant will be on the left, must be equal to the number of atoms after the reaction. After the reaction is basically your products, so your products are on the right hand side. So looking back at your equation above, let me count for you. There's no number there, meaning 1 there. You cannot change the number at the bottom. You can only change the number in front. Never ever change the number at the bottom because there is fixed according to bonding. Alright, so carbon, there's 1 times 1. There's 1 carbon on the left. There's 1 times 1. So there's 1 carbon on the right. Carbon is balanced. Oxygen, there is 2 in this compound. In this formula, there is 1 at the moment. 2 times 1 is 2 oxygen atoms. At the moment here is 1. So 1 times 2 is 2. So this balance out entirely. So this is one of the easier equation to actually balance out because you can count. You write, you count, and you make sure that it's balanced. Put in the state symbol. State symbol meaning solid is bracket S, liquid is bracket L, gas is bracket G. Carbon is a solid at room temperature and pressure. Room temperature is 25 degrees Celsius. If you have carbon in front of you, think about your pencil. Your pencil is made of carbon, it's a solid. Plus oxygen. Oxygen is a gas. It's a simple covalent molecule with a low boiling point because it's a covalent molecule, simple covalent molecule. And then CO2 is a gas that you are breathing out right now as you are living and respiring. So it's a gas as well. Moving on to the next part. So they want us to write balance equations for these following reactions. They haven't asked for stat symbol. Question does not ask for stat symbol. If a question does not ask for stat symbols, we don't have to worry about it. Only when the question specifically asks for stat symbols, which you know how to read, then you will be okay. Oxygen reacts with hydrogen to form water. So oxygen is O2, reacts with hydrogen, which is H2, to give you water, which is H2O. So H2 and O2 are among this batch of diatomic molecule. Two or more atoms, not two or more atoms, I beg your pardon, two atoms combined together to give you diatomic molecule. So these are diatomic molecule. This is not diatomic. Water is something you will have come across as your covalent bonding case study. So you have oxygen dot cross hydrogen, oxygen dot cross hydrogen. But oxygen, just like in CO2, is 2,6. So 6 outer shell electron uses only 1 and 2 for bonding. You still have 4 more. Okay. So let's start counting the atom. So there's 1 times 2, which is 2 oxygen. At the moment, there is 1 times 1, which is 1 oxygen. So 2 oxygen here cannot be changed to 1 because it's diatomic molecule. 1 oxygen there cannot be changed to 2 because this is the formula for water. And you are stated in the syllabus that you should be able to state the formula of elements and compounds at the beginning of this chemical formula in equations topic. I cannot change this number at the bottom, but I can change the number in front. I need to make it until something give me 2 oxygen. So 1 times something will give me 2 oxygen. So I need to put 2 in front. Okay, so 2 in front will mean I have 2 H2O. It means I have H2O and H2O. I hope you can then see 1 oxygen, 2 oxygen. Or there's 1 oxygen there. 1 times 2 is 2 oxygen. 1 times 2 is 2 oxygen. Oxygen is balanced. Let's have a look at the hydrogen. The hydrogen now, you have 2 hydrogen plus 2 hydrogen is 4 hydrogen. Or 2 times 2 is 4 hydrogen. I have 2 times 1, which is 2 hydrogen. So what I can do is I put a 2 in front. 2 times 2 is actually 4 hydrogen. Okay, so that's how you balance chemical equations. You count the atoms, but you cannot change the formula of the molecule or the compound because those are fixed as a result of structure and bonding. That was the previous topic, and you can look through the lecture tutorials and your notes for that particular topic. If you want, you can put in the stat symbols, but the question hasn't asked for stat symbols, so there's no point of wasting time on that. But this will be gas, and also liquid. So if you want, you can do this. But if the question asks you to, you have to put it in. So this is liquid water. Moving on to the next one. So you have hydrogen plus nitrogen. As you know, nitrogen is another diatomic molecule, 2 atoms bonded together. Ammonia is NH3, just like H2O and CO2. NH3 is another case study that you have got to know how to draw. It has got a lone pair, meaning 2 electrons that are not used for bonding. The dot and cross, 1 dot and 1 cross because 1 covalent bond with each of the 3 hydrogen. And nitrogen is in group 5, so you only use 3 out of 5 outer shell electrons for bonding. You still have 2 more, and that is what a lot of students forget to draw. And when you count, you only have 2, 4, and 6. That's why you have to have the 8, because there was the objective to complete the outer shell. There's always the objective for stability, and also the purpose of it forming only 3 covalent bonds is so that you only need to share 3 electrons, 1, 2, and 3. You still have 2 more out of the 5 in the outer shell. Let's try and balance this equation. At the moment, there is one NH3 means one nitrogen there times 1. So there's 1 nitrogen atoms. But here there's 1 times 2. So there's 2 nitrogen atoms. So what I can do is I can put the 2 in front of NH3. What this means is I would have NH3 and NH3. What this means is I have 1 and 2 nitrogen. To balance out this nitrogen on the left hand side, 1 times 2, 2 nitrogen, 2 times 1, 2 nitrogen. Happy with the nitrogen? Let's look at the hydrogen. The hydrogen now, you would have 3 hydrogen and 3 hydrogen, or you can imagine 3 times 2, it means 6 hydrogen. But here I only have 1 times 2, which is 2 hydrogen. So to get 6 hydrogen, I must do 2 times something, give me 6. 2 times 3 will give me 6 hydrogen atoms, and that is 2 times 3 give me 6 hydrogen atoms. So these things are balanced. Hydrogen is a gas, nitrogen is a gas at 25 degrees Celsius, NH3 is also a gas at room temperature, which is 25 degrees Celsius. Room temperature is 25 degrees Celsius. So these are all gaseous reactions. Last but not least, we have iron trioxide, which is actually an ionic compound. You have learned the term ionic refer to metal and also non-metal. Your iron has lost electron to give you Fe3+. That is why this is the valency. We talked about valency back in the second part 2 or part 3 of this lecture tutorial. Oxide comes from oxygen having gained 2 electrons to complete the outer shell. Metal lose electrons to complete outer shells. Well, actually, it is not complete outer shell, but this is just plus 3 because of the valency as stated there in the Roman numeral. The valency there is 2 following the charge. The valency there is 3 following the charge. You cross multiply the valency, meaning the numbers only. You don't move the ions, you move the number. So 3 will go to the right hand side, 2 will go to the left hand side. What these 2 means is I have Fe3 plus 2 times. What this 3 means is I have O2 minus 3 times. So what it means is I have 2 of these and 3 of these for the formula of iron trioxide. So it's 2 of Fe3 plus and 3 of O2 minus. 1 and 2, 1 and 2, 1, 2 and 3. I've got 3 O2 minus. The compound has no charge. That is the purpose of doing this cross multiplying thing. Plus 3 and plus 3, total up is plus 6. Minus 2, minus 2, minus 2 is minus 6. The sum of the charges give you 0 charge for the ionic compound. This is actually lowest common multiple called LCM in primary school mathematics. Now Fe2O3 is the formula for iron trioxide plus carbon monoxide. Mono means 1, so plus CO. Oops, I don't know why that didn't come out. Alright, plus CO give you iron. Iron is element. And then carbon dioxide, so there is 2 oxygen. Now you got to try and balance this equation. It's one of the hardest one to balance actually, but it's one of your important case study as you will learn it in year 11 again, but it's the same skill. Let me try by putting 2 there because there is 1 times 2 iron, so I want 2 iron. Okay, now I have 3 oxygen, so if I put, what can happen here, you need something. If I try with the lowest number first, at the moment it's 1, so 1 carbon give me 1 carbon. If 1 carbon dioxide, so 1 times 2 give me 2 oxygen, but I've got 3 oxygen here, so clearly this cannot be 1. If I put 2, then I will have 2 carbon. I can put a 2 here, but I will have 4 oxygen. I will have a 3, but because of the 2 carbon, I will need 2 here. So 2 carbon and 2 carbon is happy, but I've got 2 times 2, which is 4 oxygen. 3 oxygen, 3 times 1. 2 times 1 is 2. This is a plus, so 3 oxygen. 3 oxygen plus 2 oxygen is 5 oxygen. It's not 4 oxygen, so this number is no good. You go to the next higher number. So 2 is no good. You go to 3. You always try from the lower number first. And because this is 3 carbon now, this cannot be 2 carbon. This has to be 3 carbon as well. Now let's check. 3 carbon and 3 carbon is happy. 3 times 2 is 6 oxygen. 3 times 1 is 3 oxygen. 3 times 1 is 3 oxygen, but 3 oxygen here, 3 oxygen there, 6 oxygen total. 3 times 2, 6 oxygen total. So this equation is balanced by having this in this particular number. One of the hardest one to balance, but one of the most important one, because you will see this in year 11 again, but it's the exact same concept that you have learned in year 9. So make sure you never lose the skill. Fe2O3 comes in as a solid ionic compound, have very high melting point and boiling point. And you have carbon monoxide, which is a covalent molecule. So it's going to be a gas, just like carbon dioxide, and your iron is a solid as a metal. Okay, I think I'm done with that. I'll just very quickly highlight to you that there are some general word equations stated in your notes that you're supposed to be able to do. Later on in year 10 or year 11, as part of this 3-year program into the Combined Science 5129 syllabus, you will learn that all acids contain H+. Just to remind you, there are 3 acids altogether that you must know. Hydrochloric acid is HCl aqueous because it's a mixture of hydrogen chloride dissolved in water. They give you chloride salt because they give you H+ plus Cl minus. The chloride is basically the formula of the chloride ion. After the chlorine atom gain an electron, gain 1 electron, that's why minus 1 charge. Sulfuric acid is H2SO4. You have seen it, I think, in part 2 or part 1 of this lecture tutorial series. They will give you H plus and then SO4 2 minus. This is sulfate. It was in the table that you're supposed to master. Sulfate ion is SO4 2 minus. Nitrate, on the other hand, comes from nitric acid. HNO3 is the nitric acid, and nitric acid will give you H plus and NO3 minus. So this is your nitrate. So never get confused between the names, because the names are your vocabulary, and if you can't master vocabulary, then there will be huge implications on what you can and cannot do. So make sure whatever you do, first of all, you either know the ions, because you know the ions represent the acid. The ions come from the acid, and acid contain H+, and you can just recombine them with H+ to give you the formula of the acid. Whatever you do, if there's something you have to remember, HCl, H2SO4, and HNO3. Do not just remember them by name, keep on pronouncing this until it becomes natural to you. H2SO4, 2 hydrogen, 1 sulfur, 4 oxygen. HNO3, 1 hydrogen, 1 nitrogen, 3 oxygen. HCl, 1 H and 1 Cl. The name is chloride salt, the name is sulfate salt, the name is nitrate salt. On the other hand, metal hydroxide, hydroxide ion is among the 5 polyatomic ions that you're supposed to master. Is OH minus, is hydroxide ion. It is alkaline. When you heard something called alkaline or basic, it means the pH is greater than 7. You will learn this again at a later stage. But OH minus can react with H+ to form water. The metal cation forms salts with the acids, such as this bunch of example here. These are all word equation. Of course, then we can practice writing a couple of things with it. Metal plus water give you metal hydroxide plus hydrogen. Example, I say sodium. For example, if I use the word sodium plus water, sodium is the group 1 metal, so I will get sodium hydroxide plus hydrogen gas. Of course, then you can convert this into symbol equation. Sodium plus water giving you sodium hydroxide. Sodium hydroxide is Na plus OH minus. So when you do the crisscross, you will get NaOH. And then hydrogen gas is diatomic molecule. So here there is 1 sodium and 1 sodium. There's 2 hydrogen, but there's 3 hydrogen. 1 plus 2 is 3. So I put a 2 there. When I put a 2 there, I'll have 4 hydrogen. So if I have 2 oxygen and I have 1 oxygen here, I put a 2 in front. I get 2 oxygen because 2 times 1. 2 times 1 give me 2 oxygen both on the left and on the right. I've got 2 sodium, so there's 2 sodium. I've got 2 hydrogen. 2 times 1 is another 2 hydrogen. 2 hydrogen plus 2 hydrogen give me 4 hydrogen. 2 times 2 is 4 hydrogen. This is the balance equation. Now let's move on. Metal plus acid. Acid give you salt. Acid give you salt. You see, acid give you salt. Last time you had, well, if just above, you have HCl, chloride salt from hydrochloric acid. Sulfuric acid, H2SO4, give you sulfate salt, and then HNO3 give you the NO3 minus, which is the nitrate salt. So example, I don't know, zinc plus nitric acid. Because you use nitric acid, you're gonna get metal salt, which is zinc nitrate, and then you get hydrogen gas. For practice, you can try and get the formula of zinc nitrate. Be very careful. Zinc is zinc 2 plus, nitrate is NO3 minus. If you get the wrong formula, you will get the wrong, the wrong formula of the ions, you get the wrong formula for the whole thing. These are valency. Valency follows the charge, valency follows the charge. When you cross multiply, you bring down the number, crisscross the number, 1 goes there, 2 goes on the right hand side. What this means is 1 of Zn2 plus, what this means is 2 of NO3 minus. What this means is you have 1 zinc and you have 2 of the NO3. This is the correct formula for zinc nitrate. You might be able to write the word equation. If you can't write the formula, then you can't do much at all. On to the next one, carbonate plus acid. So if I have magnesium carbonate, for example, so this is now a metal carbonate. Carbonate is CO3 2 minus. You can refer back to your valency table with the formula CO3 2 minus. Magnesium carbonate, let's try sulfuric acid. So sulfuric acid plus magnesium carbonate will give me magnesium sulfate, and then I'll get carbon dioxide, I'll get water as well. Of course, then you can balance the formula by having Mg2 plus and SO4 2 minus. So, you can try it. Mg2 plus, SO4 2 minus. Is one of the things that I've already shown you before. So I'm not going to do it again because the focus here is just to show you this word equation. On to the next one. This is acid plus base. This is no good. I think this one is wrong entirely. Please cancel out ammonia gas. There shouldn't be ammonia gas there. Ammonia gas is in the next one. So this is basically acid plus base, give you salt and water. So make sure that you tell your friends about this. This is the wrong bit in the notes. This is neutralization. Acid plus base will give you just salt and water. So example, you have hydrochloric acid, which is HCl, and then you have sodium hydroxide, which is a base because it has hydroxide ion. You get a metal salt. The metal is sodium. The salt from hydrochloric acid is called chloride. The salt from sulfuric acid is called sulfate. The salt from nitric acid is called nitrate. And you can find that at the top of your notes, which are all given already and just explained about 10 minutes ago. Sodium chloride, don't forget your water. Water is H2O molecule. And so on and so forth. You can change the acid, you can change the base. You get salt, metal salt, and water. Last but not least, you have this thing called ammonium salt. Ammonium is an ion. Ammonium is an ion. It is NH4 and then plus. Okay, it can be ammonium chloride, ammonium sulfate, ammonium nitrate, whatever salt. Metal hydroxide contain the OH minus. So what happened then is, example, ammonium, I don't know, if I do ammonium sulfate, for example. So sulfate comes from the sulfuric acid, yeah? The hydroxide, so say if I use calcium hydroxide, I can use sodium hydroxide, potassium hydroxide, whatever you want. Metal salt, the salt comes from the name of the acid, which is the sulfate. The metal is the calcium, so I will get calcium sulfate plus ammonia gas plus water. Ammonia and water, they are among the 2 covalent molecules of which you're supposed to know the structure and bonding. I can go back to the beginning of these lecture tutorials when I talk about NH3, ammonia, dot and cross, and also water, H2O, dot and cross, all of which we'll cover in the last topic when we did covalent bonding, because all of these are very simple fundamental stuff that you do, you're building up the principles and concepts, and at this stage you should know when someone say ammonia gas, NH3, when someone say water, H2O, when someone say ammonium, it means NH4 plus, when someone say chloride, it means Cl minus, sulfate means SO4 2 minus, nitrate means NO3 minus, and the acid refer to the combination of these with the H plus. So HCl is hydrochloric acid, H2SO4 is sulfuric acid, HNO3 is nitric acid. And I think that brings us to an end to this lecture tutorial series, which is on chemical formula and equations. I have just shown you that these 5 are very powerful word equation. You can get millions and millions of examples from these just 5 word equation. Just like I said previously, there are only 5 or 6 polyatomic ions. These are the difficult ones to remember: NO3 minus, SO4 2 minus, CO3 2 minus, and OH minus for the hydroxide ions. And just because they're difficult, but then you can do a lot of formula from it, so that's why they're important. And now with these 5 general equations, if you can identify the reactant, you can identify the product, because you have learned these 5 general reactions. So make sure you practice by pronouncing them, by writing them out, by reading them, and by writing them out again and again until you're familiar with it. Okay, so that's it for this lecture tutorial series on chemical formula equations. Thank you for watching. Click the button on the bottom right to subscribe to the channel, and follow the channel and get all the notifications about all the latest videos. Please share the channel widely with all your friends, chat group, juniors, seniors, relative, etc. And follow me at ptet.chemistry. There's at ptet.chemistry on Facebook, Instagram, and Twitter. Thank you for watching, and stay safe and stay healthy. All right, see you in the next tutorial video.